So if we've got a body of mass 5 kilograms and it falls freely from rest, let's just think about that, down it's coming, and there's only one force acting on it, its weight. So how much force acts on the body? You just calculate the weight. F is equal to, and its gravitational force is equal to mass times gravitational acceleration, which is 5 times 9,8, and I land up with 49 newtons. Don't forget downwards, because they didn't say the magnitude, they just said force, and force is a vector quantity. Calculate the impulse experienced by the body. Impulse is force times time, which means it's 49, and it has 2 seconds in which it changes, and therefore it's 98 Newton seconds downwards. What is the body's momentum after this period? Well, it had no momentum to start with, and the impulse is equal to the change in momentum. So change in momentum is equal to impulse is equal to final momentum minus initial momentum. Let's do it like this actually. And the final momentum we know, we don't know, but the initial momentum we know is naught. So therefore that must be equal to 98. That's 98. And you can say Newton seconds again, or you can say kilogram meters per second. And don't forget a direction again, it's downwards. Then you have got what is the body's speed at the end of this period? Well, now you just have to kind of undo this. You've got mass times velocity is equal to 98. So momentum is equal to mass times final velocity. 98 is equal to 5 times some or other velocity, and that velocity is going to be equal to 19,6 meters per second, and it's a speed, so I don't need a direction. Don't put anything over there. A gymnast of mass 60 kilograms falls vertically downwards at a speed of 6 meters per second just before landing on a trampoline mat. Taking the upward direction as the positive direction, calculate the momentum at this instant. Well, momentum is equal to mass times velocity. We've got a trampolinist, she's 60 kilograms. The velocity, they tell me, is 6 meters per second, and therefore they're saying up is positive, so I need to consider that downwards is negative, so it's negative, and I land up with negative 360 kilogram meters per second, which really means that it's 360 kilogram meters per second downwards. The next question is, if she rebounds at an initial speed of 5 meters per second, calculate her momentum immediately after the collision. So the momentum is equal to mass times velocity, and that is equal to 60 times, and now she is going up, so it's positive, and we land up with 300 kilogram meters per second. But this time, this one is up. So we had down and we had up. And what is the change in momentum? Change in momentum is equal to final momentum minus initial momentum, which is equal to 300 minus 360. Notice my consideration of the direction. And I land up with 660 kilogram meters per second. And in what direction is it? Well, it's positive, so it is upwards. We've now got a truck of 1,800 kilograms, and it's traveling at 20 meters per second eastwards. What is the momentum of that truck? And the momentum is going to be equal to the mass times the velocity, which is equal to 1,800 multiplied by the velocity of 20, and I land up with 36,000 kilogram meters per second, or if you prefer, Newton seconds. If the truck was initially at rest, for how long must a constant force of 2,400 newtons east have acted on it for the truck to have acquired the momentum that came in the first part where it was going eastward? So we're going to say force times time is equal to change in momentum. The force that was exerted was 2,400. The time is what I do not know, and I know that my change in momentum is 36,000. So that time turns out to be 15 seconds. For how long must a constant force of 3,000 newtons act on the moving truck in order to change its velocity from 20 to 25 meters per second eastward? Well, I'm going to say, first, force is equal to mass times acceleration. And I have got 1,800. I've got as a mass, force is 3,000. And my acceleration turns out, therefore, to be 1,67 meters per second squared. So now I simply substitute into an equation of motion. I could have done this using impulse and initial momentum and final momentum. I happen to find equations of motion easier. So if I'm looking for the time, I'm going to say v is equal to u plus at. My final velocity is 25. My initial velocity was 20, 1,67 t, and my time turns out to be 3 seconds. We've got a velocity of gas from a rocket is equal to 1,8 times 10 to the power of 3 meters per second. They tell me a mass of the gas that leaves each second, so we now need to know what is the force on that particular rocket. I know that that rocket, the gas must have started with no velocity at all, so the change in momentum is equal to the final momentum minus the initial momentum, but the initial momentum was 0, so it doesn't make any difference at all. And we do know that change in momentum is also equal to force times time. So I am told that I have got 5 times 10 to the power of 2 as a mass, a velocity 1,8 times 10 to the power of 3, and this is all happening per second. So the time is 1 second, and I find that the force turns out to be 9 times 10 to the power of 5 newtons that is exerted by the gas. If the mass of the rocket is 2,000 kilograms, what acceleration does it experience? So now we have got F is equal to ma, and we have got 9 times 10 to the power of 5 is equal to the mass of the rocket is 2 times 10 to the power of 3, and my acceleration is going to turn out to be equal to 450 meters per second squared. And what is happening is that because of Newton's second law, the mass of the force of the gas on the rocket is equal to the force of the rocket on the gas. So whatever I landed up with the force acting on this rocket over here, that's the force on this mass, and therefore the acceleration is 450 meters per second in direction of rocket movement. We've got a television screen, and it's bombarded with 10 to the 15 electrons every second. So I've got a time, it's 1 second. I've got a mass of 10 to the power of 15 times by 9 times 10 to the power of negative 31. Because every one electron has got that mass, but I don't have one. I have got 1 times 10 to the power of 15. So I'm going to land up getting a mass of electrons, and they have a speed, v is equal to 6 times 10 to the power of 7 meters per second. The question is, what is the force on the screen? So let's take a look. Force is equal to change in momentum divided by time, which is equal to, these electrons all started off stationary. So I'm going to take the mass, which is 1, because momentum is mass times velocity. So it's 1 times 10 to the power of 15 times 9 times 10 to the negative 31. Multiplied by the speed, which was 6 times 10 to the power of 7, and divide that all by the time of only 1 second, and I land up with 5,4 times 10 to the negative 8 newtons. It's not difficult, it's just a little bit ugly because of how many scientific notations are inside there.